All right, so today we're going to start studying about polar coordinates, okay, in section 5.1. Up till now, in most other classes, you've probably used a grid like that for graphing. Okay, you've got your x and y axis. And this works great, especially for drawing lines. Okay, if you've got 2 points and you want to draw a line, it's very easy. What this kind of grid doesn't work well for is like circles. Okay, to try to sketch a circle on this grid, it's not designed for that. You can do it, but it's much more complicated. Okay, and we'll, if we have some time, we'll look at the equation of a circle, kind of trying to draw it on this kind of grid, and then we'll look at it drawing it on this kind of grid. Okay? As you can see, this grid is already circular, so it's set up for drawing circles. What's difficult on this kind of grid is drawing lines, okay? Because it's not really, you can do it, but it's not designed for it. Okay? So that's what we'll start off with. Okay, so instead of using an XY pair, we can also use what's called polar form. Okay, has anybody ever used polar coordinates or graphing? Yeah. Okay, and the idea of polar form is instead of having your grids running up and down and left and right, you've got these concentric circles. Okay, the horizontal axis we call the polar axis. And just like we've always done, 0's at the right, 90 at the top, 180, and 270 is at the bottom. Okay, the center, you could call it the origin, but in polar form we normally call it the pole. And just like when you have a rectangular grid, you don't have to graph a point right on a line. You can be in between lines. Just like if I asked you to graph the point 2.5, comma 3.5, you got to go in between grid lines. We can do that here too. Does everyone have the top part? So the idea of how we write a point in polar, it's still two values in parentheses separated with a comma, except we're not using x and y. We're using an r and a theta. Okay, in terms of a circle, what word can you think of that has a lot to do with circles that begins with r? Radius. Yeah, radius. Okay, so r is going to be a radius. It's going to be a distance from the center out. Okay, a certain number of units. And what about theta? What does that usually represent? It's an angle. All right, so what we'll end up doing is we're going to move out a certain number of units from the pole. And then from that point, we're going to move a certain number of degrees. Or we could do radians. Okay, either way. But r is a radius, and theta is your angle. Okay, so what we'll do is I'll give you the directions on how you graph a point, and then we'll just practice very basic, how do you graph a point? That's it. First thing we have to do is move out the number of rings, number of circles, indicated by r. Now, just like when you have an x-coordinate, there's two different directions you can move in. Okay, depending on if x is a positive number or a negative number. Well, we have the same idea here for r. Depending on if r is a positive number or a negative number, we either start by going to the right from the pole, or we go to the left. Any guess what kind of numbers, positive or negative, are going to force me to go to the right? What kind? Positive or negative? Positive, yeah. If r is a positive, you're going to start from the pole, and you're going to move to the right. Okay, so if r is greater than 0, start from the pole, or we call it the origin, and go to the right. How many units? Well, just look at what r is. How about if r is negative? If it's less than 0, which way do you think you're going to move? Yeah, you're going to move left. No. So if r is less than 0, start at the pole and go left. Okay, so in terms of like an xy coordinate, that's the first part. That's like the x. Okay, you've done that. Now we have to move the angle. Okay, so from where you already moved in step 1. Okay, so you do step 1. Keep your pencil right there. After step 1, from that point, now we have 2 directions we can move for the angle. But how do we measure the motion on a circle? We don't measure it as left and right. What are the 2 directions you can move in a circular pattern? Yep, you can either move clockwise or counterclockwise. And which direction you move is going to depend on if the angle is positive or negative. If your angle is positive, you go counterclockwise. That many units, right? Starting from where you already moved in step 1. Okay, so if theta is positive, you're going to move counterclockwise that many units. Okay, what about if you have a negative angle? Which direction do you think you'll move?
Clockwise.
Yeah, you're going to move clockwise. Okay, so if your angle is less than 0, you're going to move clockwise from where you ended up in step 1, whatever the units are on theta. Okay, so there will be a mixture of degrees and radians. If you're not comfortable with the radian, it might be easier to change it to degrees if you have to graph it. Okay, any questions on how you graph r and then how you graph the second part of that, theta? All right, let's look at an example. Let's graph the point 3, 120. Okay, so we always start from the pole, and we're going to move 3 units. Lydia, which way am I going to move? 3 units to the right. Okay, so we're going to start by going 3 units right. Okay, so now we're starting from right there. And now we got to go 120 degrees. Kyle, which way?
Right.
So when we're moving in a circle, what do I... Clockwise or counterclockwise?
One of those.
Yep. Which way? Counterclockwise. Okay. How do you know it's counterclockwise? What kind of angle do we have? Who can help him out?
Positive.
It's a positive angle. Okay. Each one of these lines is 15 degrees. So 15, 30, 45, 60, 75, 90, and then 30 more. That's it. That's your point 3, 120.
You don't draw with the angle.
Nope, we're plotting a point. Just like if I asked you to graph the point 2, 7. You just go right 2, up 7, put a dot. That's it. So we're not graphing an angle, just a point. Okay, any question on that? Right, let's try 5, pi over 4. Zach, pi over 4, what's the units on that?
I don't remember.
Well, what are your 2 choices for angular measurement?
90 and 180?
The units. What are the units we measure in?
Degrees and radians?
Degrees or radians, yep. And pi over 4 doesn't have a degree symbol on it, so
Radian.
it's a radian. All right. So first thing we might want to do is convert that into degrees If you don't have to, if you know what it is, just graph it the way it is. Does anybody remember what pi over 4 is in degrees? Yeah?
45.
Yeah, very good. That's a 45. All right, now we can graph it. Ashley, I'm going to go 5 units. Which way?
To the right.
To the right? And then 45 degrees. Josh, clockwise or counterclockwise?
Clockwise? Oh, counterclockwise?
Yeah, it's a positive angle, so that's counterclockwise. Okay, so up. It's kind of like going up, but it's counterclockwise 15 degrees. Okay, any question on that? All right, so here's another one. 5, negative 210. It's already in degrees, so we don't have to worry about that. Adam, I'm going to start by going 5 units to the right. Okay, now from that point, Sean, we're going to go 210 degrees which way?
Clockwise.
Clockwise. Okay. Sean, how much is it if I go halfway around?
180.
180?
Negative 180.
Yep. And if we go that direction, that takes care of the negative. And then we got to go 30 more. Okay, so halfway around is negative 180. And then go 30 beyond that to get to negative 210. Okay, so that first mark I just put there to mark my spot. That's the answer. Any question on that one? Okay, so that's a positive radius, negative angle. Let's try a negative radius. Okay, what could I do first here? Make this a little easier to graph. Oh, Olivia?
Convert degrees.
Yeah.
Very good. We're going to convert it to degrees. Can you tell me what that would be, Olivia?
9.
That's 90. Okay. All right, so it's negative 3 comma 90. Paige, what's my first step? Yep, 3 to the left. How'd you know it was left this time, not right? Good. Because that 3 was negative, we go to the left. And then we have to move 90 degrees. How about, Tom, which way do we move now? Counterclockwise. That's that way. Okay. Counterclockwise. Okay. Any question on that one? So you move 3 to the left, and then 90 degrees counterclockwise. Anybody see a different way to get to that point? Besides going, let's see, we went 3 to the left, and then we went that way. Okay, what would be a coordinate to do that? What's another way I could get to that point? Well, if your radius is 0, we'll see what happens, but you're always at the pole. There's only 2 choices that first number can be to land you on that third ring out. It can be a negative 3, or what other number could your radius be? It could be positive 3. So if we did positive 3, what could my angle be? Okay, so we could go positive 3, negative 90. That's another way to get to the same point. Okay. Any other way I could do it? Sean?
Negative 3 again,
Mhm.
but instead go like the other way around, like 270.
Yep. So we could go negative 3. We could go around that way. And what angle did you say that was, Sean? Negative 3?
270.
Well, we're going clockwise, so what kind of angle is negative 270? So it's negative 270. And there's one more way we can do it. So we've gone, I think we've gone right to start both ways, so there's one more going left. Yep?
3 and positive 270.
Positive,
3,
okay, yep, positive 3 and
positive 270.
positive 270. Okay, let's try it. So positive 3, positive 270. Yep. So there's 4 different ways, distinct ways to get to each point. You have a choice of going left or right. There's 2 choices. And then you have a choice of clockwise or counterclockwise. That's 2 more choices. 4 different basic ways you can go. Right? Now you might say, well, couldn't you go right and do something like this? Yes, but that's really just a repeat of going right and counterclockwise more than 1 revolution. That's not a different way to get to the point. Right? So those are the 4 basic ways we can do it. We will do that at some point. Okay, we'll go around more than once, but when you graph it, you're still just graphing a point. Okay? Normally when you graph it, we don't know how we got to the point if you just show someone a picture. Okay? But that's what's different about polar than rectangular. If you have a rectangular grid and you want to get to the point 1, 1, there's only one way to do that. You have to write this. If you write anything other than this, you will not get to the point 1, 1. So there's only one way to write a point in Cartesian. There's many ways in polar. And we did one with a negative negative just a minute ago. Okay, what's going to happen here? Yeah, it stays right at the pole. It's basically like it spins in place. All right, so 0, comma, any angle stays at the pole. How about that? Now if we switch it and put the 0 as the angle. How would I graph it?
It stays that way.
All right, what do you mean?
It's the radius around.
So would I go up 1? No. How would I get to 1?
Go over to the right ones.
Yeah, to the right 1. So you go right 1, and then you don't move up or down, counterclockwise or clockwise. Okay, so anytime your angle is 0, you're always going to be on the polar axis. You're just going to go left or right. Okay, so that's all the different cases you could have graphing a point. So now I want to look at something we did earlier. I want to take a point, and I want to write it different ways. I think what we'll do to start is let's change it to degrees because that's going to make it easier to work with. Right, so Brandon, do you remember what pi over 6 is?
30.
Yep, 30. So pi is 180. 180 divided by 6 gives you 30 degrees. All right, so the first way I want you to write this point is I want you to keep the radius positive, but I want the angle to be between 360 and 720. So you have to think how you could make this angle bigger without changing where you stop. Think about what you could add to that angle. Okay, second way I want to write it. I want the radius negative this time. And I want to pick an angle between 0 and 360. And the third way, we're going to go back and do a positive radius one more time. Except now I want a negative angle. So that's going to switch the direction. Okay, in the last case, you're going to be moving clockwise. In the other two, you're going counterclockwise. What do you think we should do? Instead of trying to just think this through in our head, what could we do that's going to make this a little easier to visualize? Yeah, why don't we just graph the point? Then we can actually draw the different directions we need to go. Okay, that makes it a lot easier than trying to think this through in your head. All right, so we've got the point 330. Let's like this. Okay, so go right 3, and then 30 degrees counterclockwise. All right, number 1. For the first one, they want the radius positive. What's my only choice? If I want to keep the radius positive and land on the third circle, what number do I have to use? Am I? If we want to land on that third circle, what do I have to use for my radius? 3. Okay, I can't pick anything other than 3. If I pick 5, I'm not going to be on the third circle, right? At least for a positive number, I have to pick 3. And now we want an angle that's bigger than 360 but smaller than 720. In other words, between 1 and 2 revolutions. So how can I take the angle they gave me and make it bigger, but not change where I land? So we're still, the direction is already determined because they want a positive angle. We have to go counterclockwise, but I just want to go around more than once. So what could we do to 30 degrees to make it bigger? Yeah, add 360. And what would that give me, Adam? 390. Good. There's another way to get to the point. Just going around one extra revolution. If I wanted you to go around between 2 and 3 times, you could just add 360 again. Okay, second way. Okay, this time they want r less than 0. Okay, so Amy, what number would I have to pick for my radius if I want to land on the third circle, but I want it negative? Negative 3. The only 2 options for the radius in this problem are 3, negative 3. All right, now I think it's going to be helpful to draw it. So we're going to go 3 to the left. And they want a positive angle. A positive angle. Which direction does positive angle go in? Counterclockwise. So we're going to go like this. Once we sketch it, then I think we can just count how many degrees we had to move. So max, how many degrees did I have to move to get to that point?
Well, 180 right across.
Yep.
Plus 30.
Plus 30 more, which is
210.
210. Good. There's a second way to get to the same point. And the third way. Okay, back to a positive radius. Okay, so Kyle, if I want positive radius, what number do I have to pick?
3.
Got to pick 3. So we're going 3. And now this time they want a negative angle, so it's going to go the other way. Okay, so let's sketch it. So we're going to go 3 to the right, and then we're going to go clockwise. Okay, almost all the way around. Okay, we're just 30 degrees shy of going all the way around. So, Sarah, what would my angle be for that?
330.
Negative 330. Yep. And there's 3 different ways to write the same point in polar. Okay, if you don't want to make a sketch, you don't have to, but I think the sketch helps you so you don't have to try to think through what the angle is in your head. Okay, the radius, that's easy. The angle can be a little harder. Any questions on that? Okay, so sometimes what they're going to ask us to do is take a point that's in polar and change it into what we're more familiar with, rectangular. Okay? And we're also going to do it the other way, but not today. Right, so let's look at how we would change this point from polar to rectangular. Okay, if you're given a point in polar, what are the two things that they give you? They don't give you x and y. They give you r and theta. And your goal is to get x and to get y. Okay, so I have a point here. Okay, we don't know what its radius is and we don't know what its angle is. So let's just call it r theta. First thing I'm going to do is I'm going to draw a line from that point to the pole. How long is that line?
R.
Yeah, it's r. It's your radius. It's the distance from the center. And that would be on a circle. So if I were to put in the circle, it would be something like that. So it's a point on a circle of radius r. Okay, the other thing that they give me is theta. Okay, well, theta is right there. That's the angle that you've moved. Now somehow I need to get an x and a y value out of that. I need to change r and theta into moving horizontally and vertically. So what shape do you think I could make out of this that would help me to do that?
Triangle.
Yeah, I'm going to make a triangle out of it. So I'm going to draw a line straight down and over. Okay, and that's a 90. Okay, the length of the bottom side, that's x. That's going to be our horizontal distance. And then the height of the triangle is going to be y. So now we need to find, let's start with x. We're going to know r. Okay, they're going to give that to us. We're going to know theta. They're going to give that to us. The only thing we're not going to know is x. So we have a function that relates these two sides, x and r, in a right triangle. Does anybody remember which trig function uses x and r? Cosine, right. So the cosine of your angle equals, and it's a fraction. Can you tell me which one goes on top?
Blanking out.
You got a 50-50 chance. It's not the one that comes first alphabetically.
I'm forgetting the word.
Well, it's either x or r.
Oh, yeah, that's right. R over X.
And the one that goes on top does not come first alphabetically.
Oh, yeah, X over R.
X over r. So the cosine of theta equals x over r. Remember, cosine is adjacent divided by hypotenuse. Okay, so the side adjacent is x, and the hypotenuse is r. Andrew, how would I get x by itself?
Multiply by r.
Yeah, just multiply by r. Multiply by r. Okay, and here's a formula for x. Take the cosine of your angle, multiply by the radius. And that'll tell you the horizontal part of the coordinate. That's x. Now we'll do the same idea again to find y. Ashley, do you remember which trig function would involve the side that's opposite and the hypotenuse?
Sine?
Sine, yep. So sine of my angle equals opposite over hypotenuse. Opposite is y, hypotenuse is r. And same thing we did last time, we want to get y by itself. Okay, so Sean, how would I get y alone?
You would times r,
Where?
like on both sides.
On both sides, yep. Multiply both sides by r. Okay, and we get a formula that says if you want to know the y value, take the sine of the angle and multiply it by the radius. So even though we're doing things on a circular grid, triangles still come in, right, when we're converting between polar and rectangular, or rectangular and polar. But this is the way we're going to do it for today. All right, so if you have a point in polar, and the coordinates of it are r comma theta, use the following formulas to change it to rectangular. Same formulas we just had on the other page. So x equals r cosine theta, and y equals r sine theta. Any questions on those two formulas? Which trig function didn't we use that we do use a lot, but we didn't use here? Tangent. We didn't use tangent. So when we talk about changing something from rectangular to polar, going the other way, we are going to use tangent. And what other theorem do we use a lot? When you have a right triangle and it has to do with all the sides. The Pythagorean theorem. We didn't use that here either. But tomorrow we'll be using that as well with tangent when we convert the other way. All right, so let's convert the point 6 comma pi over 6 to rectangular. Right? There's no need to change the radians to degrees. You can just change the mode on your calculator and plug it in. So let's start off with x. Shelby, what's going to be my formula to get x?
R cosine theta.
Yep, r cosine theta, and then can you plug in what we have?
6 cosine 30.
6 cosine, and let's just leave it in radians, that's fine.
Okay, pi over 6.
But yeah, she said 30 degrees, that's perfectly fine. If you want to change the mode on your calculator to degrees and do it that way, that's fine. Okay, and how about y? Tom, what's my formula for y? Yep, 6. 6 sine. Pi over 6. Yep. Good. Let's plug that in and see what we get. Okay, since I wrote it as pi over 6, I'm just going to leave my calculator in radians, and I can type it in exactly the way it appears. 6 cosine pi over 6. And let's put it in radians. Okay, so I get about 5.20. A lot of times when you have a point that was very nice to write in polar, like 6 comma pi over 6, when you change it to rectangular, it can get messy. Okay, so just round it off. And for y, just same thing again. Change cosine to sine. 6 sine pi over 6. Okay, that one came out. Good. 3. Okay, so now write your coordinate. 5.20, comma 3. Hey, any questions on how we converted that to rectangular? All right, now what I'm going to do is I'm going to graph it. Okay? I'm going to graph it in two ways. First, I'm going to graph it in polar. And as somebody had said earlier, that's 30 degrees. Anytime I graph, I like to change to degrees because that's more familiar to me. Okay, so let's go to the right 6, and then up 30 degrees. Okay, any question on that? That's the point when you graph it. Now what I'm going to do is I'm going to take a rectangular grid. Okay, I'm going to drop it right on top of the polar grid. And if I converted this point correctly, when I put the rectangular grid right on top of this, that point should look like it's a little more than 5 units to the right and about 3 units up. I just have to find the grid that's the same scale. So let me see if I have it. So let's check. So it looks like we're a little bit more than 5 units to the right. We had 5.2, and it is 3 units up. So that point landed exactly where it should have. Okay. Any question on that? All right, so I won't do that for all the points, but it is kind of it's kind of a neat way to just check and see, did your conversion work? Obviously not easily doable on a test, but you can do it on something like that. Okay, so give that one a try. See if you can convert -4 120 to rectangular. Just because the radius is negative, that doesn't affect anything. All right, so let's convert this one. Okay, for x. Okay, anybody have the formula that you need to find x? Good. -4 cosine 120. Okay, we'll do it out in a second. And how about to find y? Yep, -4 sine 120. Okay, just type them in. For this section, you can round 2 decimal places is fine. Because when you're graphing, I mean, you really, by hand, you can't even graph better than like a 1/10 by hand. So, -4 cosine 120. Okay, before I hit enter, what do I have to be careful of? If I hit enter right now, this is going to give me the wrong answer. It's still in radians from the last problem. Okay, and I know this is a degree because 120 had a degree symbol on it. Okay, so we get 2. 2 for that, and for y, let's type the same thing in, change cosine to sine. So -3.46. Yeah, how many people got those as their x and y values? Yep, good. Okay, just don't forget, if they say to find a coordinate, which they did, converting it to rectangular, write your final answer as a coordinate. Okay? Right, any questions on how to graph a point in polar or convert something that's in polar to rectangular? Okay, tomorrow we'll convert the other way, from rectangular back to polar. So we'll reverse this. And we'll start talking a little bit about complex numbers. Okay, so if you already did those in Algebra 2, then that's going to seem very easy for the last half of tomorrow, or Wednesday, and the first half of Thursday. It's all complex numbers. And then finally, at the very end, we'll look at the connection between complex numbers and polar. All right, so on 308, again, this is due Wednesday. I'd like you to look at 12 to 26 and 40 to 46, just the evens. Okay, just evens.